Hi everyone. Tell me how are you and if you can hear me well. So here is my ShaderToy account. And we have some stuff that we can port to Unreal. So for those of you who don't know, ShaderToy is an amazing website where people create tiny shaders that serve as a picture or as an animation. There is music too, and some of them are pretty advanced. So everything there's no geometry, no nothing. It's just a single quad, okay? A single plane with UVs, and everything else is just the magic from code. So ShaderToy, classic website started by Inigo Quiles, who is also an amazing author by himself. You can find his works by IQ, yeah. And these are advanced examples, and I won't go into that detail, but just to show you the possibilities. So this is all from code. There is fake, just camera, right? It's a manually written renderer. But if you were to just output the UVs, or just the color, let's see, half, 1, 1, 1. Okay, it won't compile. It won't compile because it has to be here. Yeah. So this is a single flat color. The coordinates, from what I remember, here's the help. The coordinates are frag coord. So in frag coord, I think. Was it in? Let me create a new one. Just frag coord, okay. By resolution, so for now just by 1000. Or 500. Yeah, so you can see here the coordinates of this piece of the screen, the viewport, let's say, okay? And everything else, everything that's happening here, just uses this UV's disposition to create perspective, to calculate lighting, and so on. Need 10 Canadian corn dog, thank you. So yeah, this is ShaderToy's power. I really recommend to check out what's there. However, I will pick something much simpler for today, which is this. I think we can start with that. This is not so long, though it has a lot of constants. This is my fader that just creates this fruit pattern, repeated, slightly shifted with each row, and it blends between them. But it doesn't blend the final result because it would look more like frame blending. It blends the spaces, the parameters basically. So the number of seeds, the shape of the of the fruit. So I have apple space, banana space, orange. Orange is very simple. Then I have the seeds where you say which fruit type. And then I just calculate like the final shape, the masks, use the right colors and output it to the screen. So let's do this as the, let's say, final thing. And first we can try something easier just to start. Maybe this. This is the normal map. Normal map from height. Let me show you the height. Okay, height is here. Main image. So let's say calc height Okay. And what did it take? UVs. So UV. Oh, it's wrong. Height takes UV. What's wrong? Nothing of data. Ah. Yeah. So this is the height, also procedural. And out of this, we create the normal map. So I think this will serve as a good first example. Short code. Banana space, Roy, exactly. Space bananas. What should we start with? Probably a plane. So let's create a new level. Or maybe just open an existing one with burning wood. And save, I don't know. Alright. And save current as ShaderToy map. Okay. What? It's crashed. Oh no. Restart. I don't know why. We'll see. Yeah, the very beginning, right? First seconds. What the? Oh no. Wait a second. Something went really wrong. What should we delete first? Or wait. Let's revert. Let's try. Okay, started. Where is the map? Maps. Okay, pentile screen, maybe better. Cool. Remove. What's this? Okay, let's try this. Save current level as ShaderToy map. Already exists. Yes. Perfect. Didn't crash. We are lucky. Okay, here it is. Let me just create. That's the blueprint. I don't need a blueprint. Just a plane. Okay. Smaller. Beautiful. Perfect. Field of view 75. What's this? Sound? Player start is in a very wrong place. Okay, cool. So we have that. Okay. And now content shader toy. So hi Mateas, hi Kazio. First I will explain the differences between, or maybe no. First I will show you the nodes and then show you the custom node, which allows you to write in HLSL, and then explain the difference because ShaderToy is using GLSL, the OpenGL language, while Unreal is using HLSL, which is DirectX. The differences are really minor. ShaderToy normal from height. Okay, let's slap it on it. And here we go. Okay, so first things first. How I would approach disassembling a ShaderToy to move it into Unreal. So for me, the most important thing is to look at the output. So where is the final color? It's here, because in ShaderToy, frac color is one of these. Where is it? Yeah, output vector 4 frac color, and input, so read only frac coordinates, which are UVs, not UVs, pixel position, but in pixels. You have to divide it by resolution. But we don't care because we already have UVs here. So this part we can skip. So I'm just interested in the fact that we have UVs. We run calc normal, and this normal is rendered on the screen here. It's actually not a normal, not a unit vector, but a normal map, because it's from 0 to 1, not from -1 to 1. So yeah. So first thing we need is frac color equals vec4 normal 1. This normal is calculated out of UVs somewhere. So in the calc normal function, it's here. But then of course it becomes complicated because we have a lot of math to do. So what I would do is try to comment out as much as I can to understand what's happening. Here I of course know what is happening, but you know, if this was a new shader for me that I just found, I would like to do that. So okay, it returns normal packed. Let's for now just return at the very beginning. Wait, does it support multiple commenting? No. Oh, that's bad. But anyway, you can comment a big chunk of code by /***. This whole code is commented out, it won't do anything. So let me just return vector3 as stated in the function's definition. Return vector3, let's say 0, 1, 0. And let's see. Okay, perfect, right? We have the color. So I will get rid of that. And now let's try. It does normal packed, normalize. And yeah. Let's try how much of this do I need. But I think I will need the most of it. Probably yes, because otherwise it will be just constant. Okay, but I proved to myself that, you know, that this function works. So now I can have two approaches basically. I can either recreate the structure or just go with the final code. So I can uncomment this code again. However, now it points to another function, which was getting height. Yeah, samples are calculate height. So of course it does something, but this is another function. So for now, just to port part of the code working, let me do return, maybe just clamp UV 0, 1. It's not matching type. UV X. So what I'm trying to do is to have a minimal part of the code that works. Okay, it's doing something. It's a constant color, but that's fine. And I want to port the part that now is uncommented and gradually add things. So let me make it smaller. I don't think if I can I make this bigger somehow? Probably not. Okay, like this. Right. Or, okay, it's better. And how the nodes are flowing is from the left to the right. Like right is the output. So whatever happens, like if something is a mix between this and that, then you have to look from the bottom up and here from the right to the left. Because let's say you want to output, it's not base color but emissive color, opaque, unlit, right? You want to have the final emissive color, which is a mix of this and that based on some gradient, right? So I mean, I know that these are the basics, but I just want to explain to you the way of thinking. So let's say I blend between green and some, I don't know, dark blue. So this is it. So what happens here? Emissive color is the Lerp, the linear interpolation between A and B, and the alpha is even further to the left, right? If these were the outputs, here we have the mask. So in code, in ShaderToy, if we were to write this, it would be that frag color equals this Lerp. In HLSL it's not Lerp, it's mix, but whatever. Between A and B using alpha. Okay, this would be the code. And then before that, so higher, I would have that vector 3A equals vec3 0, 0, 9, 0, 205. Vector 3B equals, what is it? 0, 0, 3, 0, 0, 6, 0, 4, 3, 9. And then my float alpha would be UVG or Y. Quilly Willy, hello, how are you? So this is how the code would look like on ShaderToy, except that Lerp will be mix. So we are going here, like the bottom is the result, and everything that is used for this result has to be specified before that, so higher. And in nodes, it goes to from the right to the left. So you can see the alpha here, but the Lerp, the last thing here, right? Straightforward, but I just wanted to remind you like the flow, because now you will know how we'll approach this. So we have the main image. In ShaderToy, main image is like the final loop, like this is this plus its inputs. And we have function used here, calc normal, which uses another function, calc height. Of course, it could be just, flowing. It doesn't have to be divided into functions, but it was done that way for easier maintenance, for readability, because then you can fold. So, okay, first thing we need to do is to see that frag color is a vector 4 of normal and 1. 1 is just the alpha, so we can skip that. We just need this, vec3 normal, and it equals calc normal. So the first thing I will do is not a function yet. I will just start with a comment, and let's call comment, and let's call it calculate normal, or maybe just calc normal, just to be consistent with ShaderToy. Okay, so here we go. Here we go. And what does it have? It has UVs as its input. So text coord as its input. And then it has here aspect ratio. We don't care, I think. Kernel size. Kernel size is vector this times aspect ratio. We skip aspect ratio, so just that. Wait a second. I will try to fit it on the screen, maybe. Okay, cool. Even better, to be honest. Huh. Or not? Okay, maybe no. Okay, a second. Cool. So this calc normal thing, aspect ratio kernel size. So kernel size, vector 2, 2. And this is basically, wait. 0, 0, 0, 1. Like this. And also one thing, please don't try to change things like mid-flight, okay? Just literally port it. That's my approach. And then tweak it. Because otherwise, you will never know if you achieved even the basic result. So it will be harder for you to find a bug if you change something in the middle. Quilly Willy asks, what are we up to? So we are porting a shader from ShaderToy, which calculates a normal map from height. Like this. Like this. So the height is just a, a bell curve, a hill. And we just try to understand the process. Okay, so again, we have kernel size. This is it. Let's name it just for clarity. Kernel. Great. Now the UVs are an array. Basically, array is a list of things. Then you later in access by index. So 0 is the first thing, 1 is the second thing, and 2 is the third thing. So the cool thing about arrays is that you have everything in one place, okay? You have just an array of different UVs, like center to the right and 1 pixel to the top. And all of them are called UVs, UV0, UV1, UV2. So we don't have arrays, unfortunately, in nodes. We don't. So we'll have to create it just like a separate thing. So UV are here. This is our UV. And from this, kernel size UV. And from this, we need to first take it literally. So we root. Then we need to do add plus, okay? Add kernel size. This is it. And then we have, no, it's wrong. Kernel size should be just a single scalar. Let's name it kernel size. And default 0.001. So basically a very small number because we just want 1 pixel to the right, 1 to the top. Doesn't have to be exact pixel, but just to sample. Okay, so kernel size is here. And if we are to create a vector 2 out of kernel size and 0, we need append. Or we need to make float 2. Whatever you prefer. So append this plus 0 will be here. And append 0 plus this will go as the third UV, so UV2. To the right, to the top. We can also name them, of course. This UVs. Wait a second, it has to be much, much bigger. In Unreal 5, fortunately, we have something called name reroute. And let's do UV center. Or sample UV right. Sample UV center. Oh wait, the color. And will be root. Sample UV top. And we have them named. Super cool. They are here. Now these are just the UVs. The samples are the actual height. So we need to calculate height. Now we don't have this function, but we repeat it 3 times. So we have to make it a material function to reuse that. I can't just put the nodes here. So materials, material function mf ShaderToy normal from height. Calc height. Here it is. Whoa, the name is so wrong. So wrong. Normal. Yes. And for now, let me just place it here 3 times. Okay. Here we have it. No outputs yet, but 3 times. And now let's go to it. Willy says that we can get the texture dimensions if we want a 2x2 pixel size kernel. But we don't have a texture. We'll just calculate the height procedurally. But I know what you mean. There was this... Actually, somebody showed me on the stream that there was a texture property node. Yeah. So just have a texture object param. Put it here. And you can read the texel size. So thanks. This will be it. If you wanted to go, like, you know. So you will add this instead. Or rather, this. If you had an actual texture. So thanks for reminding. Let's kill that. So here, this is the function. So it takes UVs. So we do input of type vector2, right? Vector2. We name it UV. As the preview, we can use actual UVs. So U. And here, use preview value as default. Yes. We have that. So, you know, if someone doesn't connect anything, it will use this. It will also work in the preview. And the output is called result. We can just call it height. Missing function output height. Yes, I know. What? Right. It's good. Save. Yes, now we take UVs and return height, which is super cool. Actually, this is so simple that we can recreate this already. I don't think we need to comment this out. Let's try. So the result is the mask. Let's go here. Or maybe here. There is some mask as the result is a float, a single number. And this is a smooth step between 0 and 1 using this mask. Smooth step is a S curve. It converts a linear curve into an S shape. So smooth step, taking 0 and 1. And then the value is some mask. So what is this mask? Mask is 1 minus mask. So 1 minus x. goes here. And as I said, from the right to the left. Wait a moment. I need to check something. Right. From the right to the left. So this small step is the mask. So we can just output it here. Of course, it now complains that we haven't connected anything. Inversion. We can use the same comments. So invert height and bell shape. Tell me on the chat if everything is clear so far, because maybe I'm going too fast. So I'll be glad to know. Clamp between 0 and 1 can be used, of course, but in Unreal we also have saturate. So saturate is a fast clamp between 0 and 1. Same thing. So we put it here. And what we do is distance between UVs and some circle center. And the circle center is here, it's constant. But actually we can take it as a parameter. So function input vector 2 and circle center. And as the preview, we can use this value of half and 0.3 or half and half, whatever. Use as the preview, yes. So distance here between the UVs and the center of the circle, it gave us the original height. Let me display that. Vec3, calc height, v. This is it. This should be the result of this function. Fortunately, here we have a plane which we can preview quickly. So let's see. Distance goes here or not yet? Distance is first divided by circle radius. So this is circle shape. And circle radius is divided by another input, circle radius. Oh, scalar float, right? 0.2. So dividing is basically scaling this distance, resizing. It goes to saturate. Okay, kind of, right? Actually, the same. One difference is that Unreal by default uses gamma to display. And this is unfortunate because I just would like to see the, the raw color, but you can emulate gamma in ShaderToy. Just do frag color equals power of frag color to 2.2 or no 1 by 2.2. So power to the power of 1 divided by 2.2, which is something like 0.4545. But it doesn't matter. Yeah, now it looks exactly the same. So unfortunately, Unreal uses gamma for displaying. I mean, it gives us pretty color, but for data, it's worse. So same thing, right? I will just disable this gamma. Yeah. So we have that. It works. Takes these params, does the thing, and gives us height. So now we have these heights here. So this is wait. Show me the normal. So now this is what we want. We have this height. basically how this shader works. It samples height at some point, then another one on top and another to the right, and it checks the difference between the value of these two heights. So let's say this is very high, like 1.0, right? This is 0.8. So it knows that it's falling. So then it knows that the normal should be that way. And the same with the top value. It knows by how much and which direction by taking 3 samples of the height. So yeah, this is what we need. So it's, where is it? Hey, the chat is silent, so let me know if everything's fine or if you have some questions so far. Calc height. Yeah, 3 samples based on all these UVs. So UV, as you can see here, UVs, top, the right, and center. And the circled center will be the same. It will be a vector param circled center and a scalar, whoops, circle radius. By the way, I have a very weird habit of pressing caps lock to enter big letters. I almost never use shift. I would like to unlearn it, but I don't know how. The radius 0.2, center half, append these 2. Okay. So it goes here. And the radius goes here. Kenshin just tries to understand what's going on. Piatnashkin says everything is fine. Oh, Piatnashkin, you changed the spelling for Romanized version? And Emanuele Celli is taking notes. Okay. Okay. So here we go. We have so far recreated the calc height is this entire function. So as a quick reminder, result is on the bottom, here it's on the right, and here we go up, here we go left. So we return smooth step, which is between 0 and 1, 0 and 1, and the mask. Mask is inversion 1 minus, so 1 minus here. By the way, you can always right click and start previewing node in Unreal to see the particular, place. What happens here, for example, what changes here, and so on. You can see now white to black, inverted, black to white. So yeah, clamp between 0 and 1 is saturate, divide, distance. Okay, here it is. We reuse this function 3 times here, so 3 times here. These are the UVs prepared. As I said, we don't have arrays here, unfortunately, so we have to create 3 separate things. But arrays are just a list of things of the same type. So in the same, a list of vector to the right, to the top, center, like here. And then this part is done. So we can go further. Difference x. So difference on the x-axis is samples 1 minus samples 0. So samples to the right minus sample origin, center. So let's also create a name reroute height center, name height right, oops, and height top. Here it is. What's with this randomization today? Okay, and the difference is between this and that one. So difference, subtract, subtract right minus center, and there is also top minus center. So let's call it difference x on x-axis, common difference on y-axis. Cool. Like it says here. Now the height scale should be a param. Height scale 200 by default. So x is dx, so difference times this height scale. And there's also difference on x-axis multiplied by the same thing. Now z. So we have, let me show you what we have. We have a plane. Very funny little plane here. And we have height. We have the difference of the height. You can see it here, you see it growing. But when I multiply, it will be more visible. Right? This is the difference between the neighboring pixels. And the difference in y-axis. So when appended, I would have this. So this is almost a normal map, but without the blue. So how to get the blue? We have to derive it so that it complements the green and red. It can't be any blue, it has to be specific one. So SQRT is the same thing. SQRT. If you type it, you will probably get the function. Same, we know, Lerp gives you linear interpolate. Dot product. So SQRT square root. So just try to type whatever is here. SQRT 1 minus this. So 1 minus x. And here is x times x, y plus y. So x times itself. Then y times itself. So this is y squared, x squared, and this is xy, normal xy. And I need to add them here, add. And then 1 minus this result, and then square root. Okay. And then the normal is normalized version of vector3 made out of x, y, and z. So append x, y, and the newly derived z. Normal x, y, z minus 1 to 1 range. Okay. Here it is, and we normalize that. So as I said, if you see a function colored purple or ultraviolet or whatever, just normalize and you will probably find it. Here it is. And then the normal packed is what I said before. It's converted into a normal map. Because this, what's Wait a second. Wait. We have this. It's okay-ish. Squared. Huh. X times X. Y plus Y. Yeah. Makes sense, I guess. We add them. And we do 1 minus X. That's weird. Or is it? SQRT. I think that they may be a clamp somewhere. Smooth snap. This should clamp already. Ah, we multiply by scale. Wait a second. This looks okay, but the normalize doesn't. Maybe the scale is too big. Let's try 1, 10, 20, 30, 100, 200, and then it breaks? What the hell? Okay, so it may be some precision issue in Unreal. Maybe. I don't know. I'm not sure. Emanuele asks, why am I adding and not subtracting? Where? Here? No, wait. Here I'm subtracting, so this is height minus other height minus subtract. Then I have multiplication by the scale. Multiply. And then I have x times x. So x times itself. Plus add y times y. And then all this is 1 minus value. 1 minus value. I think it's okay. And then it's square root. This is the same as subtract 1 minus value. This is the same, but this is faster because it's just a single node. Then there is normalize. And then to pack it, because as you can see, it's between -1 and 1. It doesn't look like a normal map yet. So to pack that, we multiply the normal by half. And then we add half. And half. Start. Yeah, now it looks like a normal map. As I said, Unreal is displaying everything in the gamma space. You would have to do power to 2.2 to get an gamma output. So similar, I would say. The height is flipped, so probably it's because I should do. Wait. Where is it? Here I added 1. I should subtract. Let me try. Yeah. Maybe this is what you, Emanuela, wanted. So yeah, it's the same. This is just gamma, just for preview. Here we have it. So now, as I said, going from the bottom to the top is the packing. Pack the normal. Pack into 0, 1 range and normal map. Or remap. Okay. Calculate normal map. from a height function based on this. Wait a moment. Yeah, then we go to this part here, calculating the normal. So let's hide it for now. Oh, by the way, the camera doesn't work and nobody told me. Guys, what's up? Cam. Where's the cam? Cam area. It's not available? What the hell? Okay, now? Nobody told anything. Ah, okay. You thought I want privacy for today. Alright. Tomorrow I finally go to the barber, so you may see me. The hair stylist. I don't know the English term. You may see me in a new shape. Finally. Kernel size. Yeah, so all this is sampling the height. Comment. Where's comment? Where is it? Sample height in 3 points. 3 neighboring points. Okay. Calculate the normal map out of height derivatives in both axes. Okay, so we did it. The simple shader is here. The simple shader is here. And as you can see, it doesn't look that scary, especially that we packed the height into a separate thing. Like this. Whoops. Okay, save. So the first example can be considered done. Here it is. Beautiful, right? Like on ShaderToy. Like here. 1 to 1. So now I think we can proceed to the fruit. I think, yeah. Just let me hydrate. But the normal map is pretty on point. It's the same. It's the same. 0. So now about this one. Let's try. And I can assure you it's possible because the first version of this I did in Unreal and only then ported to ShaderToy. So again, same process. We start from the bottom. It outputs color. As you can see, this is gamma. This is 1 by 2.2. Even the comment says the same thing, that this is gamma. It mixes three results, taking color, seeds, and fruit type. I don't know yet what does it mean. And there's also a seed mask, which is the result of a function called seeds. So let's just go, instead of trying to understand everything. One thing though, because they may be arrays taken as parameters. Mix free. So mix free is just a lerp between three things instead of two, using a factor. So when it's 0 to half, it mixes between A and B, and when it's half to 1, it mixes between B and C. So 3 inputs mixed with one factor. Like a tiny gradient, right? Gradient of 3 points. Okay, let's go. This may be problematic, this color, this arrays. But let's see. So basically these are the colors, sizes, and everything for all 3 fruits. That's why every array has a size of 3. Like apple, banana, orange, apple, banana, orange. But I think we'll figure this out. Okay, so gamma, let's create a new material. ShaderToy. Fruit anim. This we can copy. Local. Great. What the hell? What's wrong with this local space? Come on. Okay, it's good. Fruit animation. Perfect. Changing it again to unlit. Unlit. So our frag color, for those of you who just joined, is just emissive color in Unreal. We have gamma here, but maybe we won't need that because Unreal already applies gamma. Probably, yeah. Let's make it smaller. So it mixes, we need a function called mixed free. So mixed free is here. Oh, that's a problem. Because it can also mix an array of values. Huh. Oh no, it's not a problem. Or is it? We'll see. A new function. Material function mf ShaderToy root anim. Or no, just mf ShaderToy mix free. Let's go here. And what it takes? It takes, whoops. It takes value A, so function input, value A, and the preview can be whatever, use default, input B, input C, and factor. Quilly Willy asks if I saw the Unreal Engine 5 Matrix demo. Yeah, I did. I'm impressed that they created the buildings procedurally, mostly. What do you guys think about it? What were the aspects that you found surprising? Because by playing with Unreal Engine 5, we already seen a lot of this, including Lumen and Nanite. So I wonder what surprised you, basically? Because there was a plenty of nice stuff there. Factor. Oops, it's also an input. Factor. And by default it may be half. Or 0. And what it does is it has an if if 2 factors y is bigger than 0. 2 factors, because it splits the factor. So it takes the factor, it multiplies it by 2, and subtracts. We can use a remap. It will be the same thing. But as I said, I would prefer to recreate the original as it is, like literally, and only then optimize it and tweak it. Because I want to know if I recreate everything perfectly, is it the same result or not? I have an urge to replace it with a remap right now, but not yet. Not yet, because I know that this works, so I just recreate it one by one. Okay, so subtract vector 2, 0 and 1. Oops. Like this. So this is 2 factors. And then I have it in X and Y. Clamp, so clamp is saturate. Clamp is saturate. And then I can break it, so break float 2. Okay, so this is 2 factors into B and B, C. Okay. And if the green factor is bigger than 0, is bigger than 0, then return a lerp, a mix. Mix is lerp. There are a few keywords that are different in GLSL and HLSL. So comment mix is lerp. Fract is frac. And were there more? Right now I don't remember, but these two for sure. GLSL versus HLSL. Mix, lerp, practice, frac. And back free is float free. Float free. In ShaderToy, so in GLSL, it's vec free. Okay, so lerp is mix. If it's bigger than 0, then blend between B and C using that factor. Else here. Else blend using this factor between A and B. Like this. If this is bigger than 0. Okay, so it mixes 3 values. If the values between, let me draw that. So let's say we have some point on a gradient, some other, and then we have, I don't know, blue, and then the value, the factor, goes from 0, oops, 0, half, and 1. And this is A, B, C. So if the factor is between 0 and half, like 0.25, it will pick the blend of these two colors. Okay? This is how it works. This entire function. So we have that. Let's save. Vector 2. Maybe some blue or green. Blue. Okay. We can try this function. So let's go back here. Let's drag and drop it. And let's see, it mixes free, right? So let's preview. Oh, the order, sorry. 0, 10, 20, 30. Okay, good. So let's try scalar, factor. You know, we have to test this piece of code before we proceed further. EOBet asks if anyone already asked why nodes instead of GLSL to HLSL in a custom node. I don't know why. Custom node, sure, we can port the entire code. Let's do it in a second, but I would rather show you nodes because I think that work on this is very it's hard to work on this. It's not pleasant. It works, but it's not fun. That's my problem with custom node. If it had such a nice editor as ShaderToy, it would be awesome. Okay, so ShaderToy mix free. Take a look. If it's 0, it gives us the green. It doesn't. Something's broken. It should give us yellow at 0. So wait, here we have factor. It's vector free, no, scalar. Gives us factor 0. Multiplies it by 2, subtracts this. Which makes sense. And then breaks out the components. Maybe like this. Not necessarily. Wait a second. Mix 3 returns a mix of value B and value C using two factors X, so R, 2 factors X, if the value is smaller or equal 0. Smaller or equal. No. Of A and B. So this. Else it should give us that one. Okay, now it seems to work. Okay, so at factor 0 is yellow, at half it should be green, and at 1 it's blue. Right, it works. I just now slide the factor. Yeah, it works fine. So this function is already there, it's working, it's good. We know that it does work. Remap clumped. Do we have that? No, we just have remap value range. So we can make one. Remap clamped. Remap clamped. Material function. MLF. ShaderToy. Remap clamp. It takes a float. So remap value range. Function input. Scalar. 0. So range min. Use default, yes. Range max. What do we have else? New range min, new range max. Okay. 0 to 1, 0 to 1. Target load, input high. Right. And the input value, of course, the value. So, value. 0. And sort order like this. 30, 40. Yobet said that they just had to ask. Sure, thanks for asking. Always welcome. Canadian Corn Dog says that the entire material editor kind of sucks compared to just writing shaders. I mean, the thing that you can preview things and organize into groups and such, it's nice. But in general, as you can see, yeah, things become huge, which are just small in code. So code is not that scary, and I would love to have in Unreal some way of writing code better than the custom node. You know, with proper editing, syntax coloring, showing you the errors inside and so on. Even such nice things as pressing tab and having entire thing indented, it changes a lot. Or just hiding parts. Basically a good editor has to be there. And then you can be very fast in code. And it's not that hard, as you can see. Functions are the same. HLSL and GLSL are very simple languages. So it's not like learning C++. Totally not. It's just like a 30 keywords to learn. There you go. Everything else is just numbers. Super easy language, super fun to learn. Same with Vex in Houdini, very similar. You know, no complicated constructs, no classes. You just go and get math as the result. So I agree that writing code is cool. Remap value range, and it clamps. Clamps. It just clamps the input. So we cannot do that. We have to do saturate on the initial division. So divide, subtract, value minus minimum, value minus maximum. No, maximum minus minimum. Divide this by that. And saturate. And then mix is lerp. So lerp. Between new range min and new range max. Very simple function. Very similar to the built-in remap, but we saturate this. So this is remap 2, 0, 1. Oh, and Quiddy Willy, thank you for following. And Canadian Corn Dog too. Thanks a lot. By the way, are you on Discord? Quilly probably yes. Corn Dog, I'm not sure. Let me get you an invite. Where's that invite? Copy. Uh-oh, I'm in a streamer mode. What the hell? Disable. Invitations. Invitations. Edit server profile. Server settings. How can I share this? I can revoke. Cool, I would like to share. Whatever. Just create an invite. Discord. Oh, and you enjoyed the YouTube videos. Cool. So how did you find out about the Twitch? In the description? Or somehow else? Because I'm interested in, you know, luring people here. Mateus says that they wanted to see how the HDRP code looks like. Yeah, so there's one problem with the code, because sure, Unreal can show you shader code, HLSL code. You click that, and you have the code. However, this is so long because this is every function that Unreal provides, like every single thing, only to have some, in some random place, not even at the end, some random place has your code using just a fraction of these functions, because they rely on the compiler to compile out the unused functions, which is true, it does, it's optimal, but it's just, you know, it's the most like lazy approach, is just dump everything and then let compiler figure it out, but the humans can figure it out. It's like unusable for me basically. So yeah, that could be better, but at least it's there, and if you need to find things, you will find them. So yeah. Oh, a technical artist joined Discord. Is that you, Kordok? It was advertised on the sidebar. Oh wow. Okay, so hello, welcome to Discord. Feel at home. Okay, we have this function. ShaderToy. Where is it used though? Mix free. And remap clumped. Remap clumped. Whoa. Okay. Remap clumped is here. Super cool. Mix free is there. Polar angle 0, 1. It converts, it gives us angle from the UVs. Let's see if we have polar. Of course we don't. Angle? Of course we don't. Damn it. So another function, material, MF, ShaderToy. I try to be faster to save your time. I hope you can manage. Follow. Okay, so function input, UV, use preview, UV. It's here, right? And angle is atan. So as I said, you don't need to know that it's arc tangent. You just type atan, like here, like the blue thing, and it will find it. The same about frag, the same about lerp, linear interpolate, sqrt, and so on. Okay, so atan, arc tangent fast. Let's use the fast one. I don't know if it's really fast. I think it's heavy, but whatever. Probably faster than the other one. UVX, UV1, yeah. Remap clamped. Oh, take a look. It's our function. Our function. Remap clamped. Okay. And these remaps minus pi to pi. Do we have pi? Just pi? Yes. Oh god. What the hell? It's just this? It's just a number packed. Whatever. Pi. Oh great. I can do already a multiplier by -1. Hell yeah. Minus pi to pi. 0 to 1. And the value is this arctangent, so the angle in radians. And that's it. Yeah. Cannot cast to what? It's vector 2. I need to hydrate. You hydrate too. It's a usual programmers and computer artist problem. Piatnashkin, it uses the wrong number inside? What the hell? 31.142 was pi. Python. From math. Import pi. Pi. 3141592. It should be fine. 593. God damn it. But I won't change the, in-engine function. So it's even wrong. What the hell? Let's do it better. Let's copy. Scale down. Paste. Now it's better. Pi. Wrong number. Awesome. Multiply from minus pi to pi. Such multiplications are not an instruction. They are so simple to resolve that the compiler will figure it out and will replace it with the final value. So don't worry, it won't cost anything. It's not an actual multiply. Okay, remaps. Here it is. Polar angle 0, 1. What else? Polar angle 0, 1. Polar angle 0, 1. What else do we need? Background. Background. Apple space, banana space. It's quite a lot of code. Orange space. Okay, so for now, as per request by Eobet, I will show you quickly how we can do a function without nodes, just using the custom node, and you will see how bad it is, okay? So the first thing is that we created our nice functions, but we can't use them in custom. We cannot. Because how custom works? Let's see, we want to do this. Well, we can because it's remap. Whatever. Okay, we want to do this. Remap clamped. So we create a custom node. Custom. Enter. And here the code is by default 1. Just 1. If you do half, it outputs gray. If you do 0, 1, dark gray. But you can also output float 3, 0, 1, 0, green. So here is the entire code in this tiny little thing in the corner, in the details panel. But you can do Shift Enter and have multiple lines. So here the remap clamp would look like this. Float, new value, equals, and the rest will be the same. Like here. Oh, yeah. Shift Enter. Then mix is called Lerp in HLSL. One of the few differences. So return Lerp new range min, new range max, new value. Here it is, the code. Completely unreadable, tiny, and it returns float. So output type is float 1. Description is remap lamp. And then the inputs. It won't work because we don't have new range min, new range max. So you add inputs like this, as many as you have here. So it takes range min, range max, new range min, and new range max. But the cool thing is that you can use actual code. So you can copy this thing and just replace mix with lerp and vec free with float free and value. Value like this. Okay, so here you have it. Outputs, inputs added, output is float 1. Additional outputs, no. If you have constants like this, that pi is something, you can do additional defines. Define name is pi, and define value is this. And then it works like the node, like this. Whoa. Similar, right? However, here you can see what's going on and zoom and preview, while in the custom node it's just a tiny code cramped into the details panel with no coloring whatsoever. If you do a mistake, let's x connect something. It crashed. Awesome. Great. Don't use it. One. Custom node just crashed. Oh boy. I wonder how much ago have I saved? How long ago did I save? Black, that's not bad yet. Fuck. But maybe the functions were saved. ShaderToy. Oh yeah, the functions are there. Remap, polar. Okay, it's good. And mix free. Okay, cool. We didn't lose that much. We just lost the damn custom node. I'm not sad because of that. Mix free. Yeah, note this again. What did we do last? The polar. Now the background. Background is this nice checkerboard. So we can just recreate this, I think. Yeah, it will be easy. So, MF, ShaderToy, ShaderToy, fruit anim, background. Okay, cool. It returns vector free. It takes UVs, of course. Inputs. UV. It takes fruit type. And it just takes fruit type. To mix between the three fruits. Three UVs. Color BG. What's color BG by the way? These are three colors that are constant. So we may need to create a material collection, actually. Let's create one. Because these are constants for the entire shader. So for all the functions. So let's create a material parameter collection, MPC, ShaderToy, fruit anim, and everything will be inside. So fruit tiling and so on and so on. Scalar params. Fruit tiling 4. Fruit distance threshold 0.45. Fruit type anim speed. Okay, so this will take me a while. I will be just clicking, so let's not read out everything. 4.5. And tiling is 10. But that's not all. There are more. Save. Now vectors. This is done. Right. Vectors. Oh. I could do that. Oh my, that's a lot of vectors. So as you can see, there's one problem of Unreal. That in GLSL you have arrays, which is very easy to use. Not so much later. Oh god. Huh, this is unnecessarily tricky. Color BG. I really miss arrays and I miss structs when you can just pack multiple different types into one. Hey, that's a lot of adding this. I could basically use Python. So color BG 0. So much. There should be a method to just copy this and just paste it. Unfortunately. Save all. Where is it now? God. 13. There really should be some way. Color page 2. That's a lot of clicking, you know. If I could somehow preview what the color is and just pick it. Okay, peel. Okay, so about this Unreal Matrix demo, what do you think? Like, what was the surprise for you? That you looked at this and then Roy said that they were switching cars to apply deformation, and Quilly Willy said it was just the overall fidelity in the large map. For me, yeah, the scale was impressive and the density of this. However, I wish that there was less of popping between LODs on consoles, but I don't know exactly what was the reason. And one thing that surprised me is that it ran at 30 FPS instead of 60. At least that was my impression. like that. And the color peel too. Yeah, so one amazing thing in this demo was how they colorized the cars, because from what I heard, they just used custom parameters. So you know, instead of this vector param, which will need another dynamic material instance, they just did same, but let's say car color, and use custom primitive data. And this you can set not per material but per mesh in the blueprint, or per instance. So you have one instance static mesh component with all the cars, and you just call set instance primitive data and send the color per instance. I don't know if it's a new thing in Unreal 5 or it was already, but that's the way to go. Super fast, you know. And it works great with Nanite, because having many objects is still problematic, but drawing many times the same instance by Nanite is fast. So you just let everything draw as an instance static mesh, and then you just colorize or change, like, you know, UV randomization or texture atlas randomization using this custom primitive data. So play with it. I have a video about that. Not for 5, but for even Unreal 4. It's called interactive materials. So it was custom primitive data. Check this. Okay, and in the meantime, I'll do that thing. I was also surprised there was very little destruction. You know, chaos wasn't present, I think. Or was it? And I just missed that. But the buildings were impressive, and how do you know the fidelity of the city, like the density of detail. Like it really worked. And also I really like the post-process and the color grading. Super nice, movie-like. Color peel. 3. It will take a lot of time. Oops, 3. No, what? Color peel? Color pop. 0. Color pop 1. Yeah, we're getting closer. Just 3 arrays, 3.5 array left. Okay. So what else do you think about the demo? What would you add, or what would, like, what it didn't answer for you yet about 5? Unreal Engine 5. Color pop 2. Also, as a lumen demonstration, it was really nice because all the night lighting was indirect. However, I always kinda cringe inside when I hear journalists saying that millions of windows were lighting up the scene, like impossible numbers, billions of triangles imported as the city. Guys, no. Like, dear journalists, it wasn't millions of windows glowing, it was a couple of on-screen pixels glowing. That's how this technique scale. Same about Nanite. It's drawing just the right amount of triangles before it falls below 2 pixels per triangle or something, or maybe even more. So there's not billions. This is even less triangles than in some released games. It's just the right amount of triangles for the distance. Fluent LOD. So yeah. But of course, it already is in many articles, including Digital Foundry, billions of triangles and millions of lines. It's just a few pixels lighting up the scene. Still impressive, of course, but thanks to cleverness, not to voodoo magic. Basically, I think this is disrespectful to the authors to imply that they brute force millions of light sources. It's much more clever, so much more interesting to talk about than some bullshit like this, I think. Color 0. So I'm impressed by the demo, but as usual, I'm not impressed with what web journalists are doing about that. Colors 1. Basically, instead of reading articles like that, I recommend Twitter and just go to the people who work in Epic and read what they have to say. There is a lot of great discussion on Twitter. If you don't know who to follow, then just come to my Twitter, so twitter.com techardate. Go to who I observe and follow them back. Somebody asks if all the interiors were full geometry or just a parallax shader trick. I'm pretty sure, I haven't seen that, but I'm pretty sure that interiors are just parallax. Maybe except for some few ones. Because I haven't seen an, see-through interior there. Ryan Brooks had an amazing shader. So he works in Epic, so I think they may reuse that. They may have reused that. But where was it? It was on his YouTube. Cardinal, hey, how are you? Great work on this recent artworks. Really, they look really fun. I know it's not true, but they kind of look effortless, like very cool exercises. They are not overdone in a sense. Really cool. Ryan Brooks interior. Interior or building? Oh, come on. Just don't tell me he deleted it. No. Here it is. Parallax fake interiors. Take a look. Piatnashkin says that GTA remasters are using interior cubes everywhere. By the way, look what I found recently by Alex Strook. A painterly shading for Unity. Made out of tiny sprites, probably. So cute. Especially how it blends everything with everything. Okay. Let's come back here to the fruit. Sorry it's taking that long, but there's a lot of parameters to type. Color 62 is this. Oh boy. if you were to recreate many ShaderToy shaders, I recommend you to create some, you know, copy pasting Python functionality to convert seeds count first last 0 1 2. So it's 8 5 7 5 0 5 7 0 6. Oh, Sambats, you shared the tweet at work. Nice. Sambats has recently changed jobs, and this new studio uses Unity. So there is according to them, there's an amazing amount of creative work done in Unity. Yeah, I'm really impressed how often people create their own art styles in Unity, because the default is not that much enforced as in Unreal. And with not much effort, you can do a lot more in terms of changing the appearance. So some companies got impressed with Unreal because of how realistic it looked from the start, but that may not be that great sometimes, because it's easier to recreate your own style in Unity, and the shaders are much more open to this. You can do some stuff with lighting and so on often. So yeah, that's true. 0 2 0 2 0 9. Look, we are almost there. 0 15 0 1 0 6, and yes, done everything. What changes to be lost? No. Okay. Okay. The background function finally, yes. Background. Okay, text UVs, BG UVs are UVs plus time. Time is the same, it's just time. Times background speed. Input in something. What was the background speed by default? Background speed. It's from collection. Yes. Collection. Fruit anim, yes. Background speed. Oh yeah, come on. Here it is. Background speed. Times, yeah. And then BGUV. We subtract half and half times background tiling. Multiply background tiling. Okay, cool. And there's the result. What's happening to the UV? What? Wait, it's wrong. We add this together. Then we subtract half. Yeah. What does it output? Whoa. It's just UV. Okay. So named VRoot background UV. Okay, cool. Now, yeah, you can see it here. Now we take this background UV and create a checker out of it. So fract is frac. Then we add half. Preview. Okay. As you can see, the moving little UVs, okay? Little UV spaces. Then we have floor to get integer here. Then we do mask, which is add, so break, float to components. Whoa. And add them together like this. Okay. Stealing of clamp. As you can see, ceiling, but clamp is inside. So ceiling will take this as the argument. Clamp 01. Clamp 01 just saturate. This. Okay, cool. Minus floor mask. Floor mask times half. Multiply half floor like this. Floor taking the mask times half as the input. And subtract this minus this. Oh yeah, we got the checkerboard. So, and then saturated. So this is named reroute checkerboard mask. Okay, and now checkerboard mask. Whoops. It mixes free again. Mixes free. Oh, okay. Checkerboard mask. It mixes free, mix free. Where was it? Here. Using fruit type as the factor. Ah, it's one of the inputs. Okay. Fruit type. So input. And fruit type. Scalar. Preview will be 0. And it mixes free. Where is it? Between background. I see. Background and background multiplied by 0.8, so darkened a little, will be mixed. So Lerp is mix. Mix in GLSL is Lerp between this and that. But A, B, and C will be this collection parameters. So collection param, background, color BG. So yeah, it's so sad we don't have arrays in this material editor and structs. Basically now it's much more backwards compared to the blueprint editor, which is great. Okay, and the output. Yay, we have the green one. If the fruit type was 1, it would be the blue one, and fruit type 2. Yeah. No, sorry. 0, half, and 1. Yeah. So here we go. We have the background. Save. Somebody says, nice. Thank you. It wasn't that hard, and all this, I always took a lot of time to figure out how to do the checkerboard, you know, the ceiling, subtracted, floor, so the mask cancel each other out, and we got this pattern. But we also can use checker pattern. Probably the same thing, you just need to animate the UVs. tiling, but I don't know about the tiling, so let's keep it that way. Let's keep it that way. Okay, we have the background. Background is here. Fruit type will be fruit type 0 to 1. 0, which is apple. Half. Yeah, I think it was like that. Half is banana. 1 is orange. Ah, the UVs are called in. UV. It's okay. Fruit anim background. Let's display that just for fun. Okay, cool. Animated. Beautiful. Background is here. Now what's the next part? Apple space. Maybe as the beginning, let's just do apple space to make this faster and without the seeds. And just try that. So we have the peel, the pulp. Yeah, calc fruit type. Where are the spaces blended? Ah, here. Okay. Calc fruit UV. Okay, so I just need, basically I just need apple space. So material, no, material function, mf, ShaderToy, fruit anim, apple space. Save. Oh. Save. Where's the apple space? Here. Okay, first there's perspective scaling. Apple I want is more conical than spherical. Remap clump, we already have them. By the way, we can just expose them. Expose to library. Then they are available in search. Library categories, TAA, ShaderToy. Expose, yeah. Wait, there are more. Let's expose everything. Huh? Where is that? Yeah. Oh, who has just joined Discord? Introductions. NRS and Electric Fisherman. Welcome. Okay, this is exposed. Yeah, Canadian corn dog. This is true. That in Unity, you just write shaders that output to the screen. You can do forward lighting. Just use the incoming lighting and do something to it. You can't do that in Unreal at all, unless you modify the engine. Okay, this is exposed. That's good. So Apple space. First remap clump from these values. Minus half. 0.4. 0.9. And 1.6. And the value is uv dot y. So we need uv. Okay, so again, this input here. We need y. So component mask y. So g. Basically, this dot something is component mask, so-called swizzle syntax dot y dot x dot z. So mask r, mask g, mask p. But you can do more in code than you can do here. For example, you can do xy xy, or xy zz, or zy xx, and you have vector 4. So this is a great syntax, this swizzle. Okay, out UVs equals UV times scale over V. Scale over V. So UVs are multiplied by themselves, just scaled. Let's see what it gives us. Ah, no. And vector 2 of scale over V and 1. 1. Whoa. And then multiply. Ah, so it gives us modified UVs. But now let's try, for example, to measure the distance between this and 0. Not yet much of an apple space. But what if I add it to it? Add and half. Subtract half. Okay, maybe it's more like an apple space. So if this is bigger than 0 or half, then do, just as a preview, you know, I'm not doing anything useful, just previewing. Yeah, it's a bit like an apple. So normal UVs, if I just took them, they would look like that. So a circle, but I multiply them by a function over V, which is slightly curved. It's created here. And it gives me this. So almost an apple. Now there is making it concave at the poles. So this is perspective scaling, this part. And this is just the preview. Let's go. Okay. Comment. Yeah. And now there's the second part, making it concave at the poles. Concave. So there's a cosine, cos of polar angle of UVs. So right to left, cosine of polar angle of UVs. Texture coordinates. Like this. Okay. Times. So this cosine is of this times pi times 4. Plus pi and pi. And the cosine of it all is the shape. Shape. Now remap value, remap clump, this cosine from -1, 1 to 0, 1. As you can see, even simple lines of code can be so verbose in nodes. So this, then there is a power to 0.25. Then again a remap clamped. Oh my god. Like this. From 0 to 1 to 1.5 and 1. And then the UVs are multiplied by it. Multiply by this. Okay, we have almost an apple. It's a little kicked to the side. I don't know why. Maybe some parameter is wrong. -1, 1 to 0, 1. Right. Then the power. Then 0 to 1. 1/2 and 1. And multiplied by the shape. What the hell? Looks good. Maybe the parameters are wrong. Remap clamped. Oh. Range min, range max, new range min, new range max. What the hell? Range min, range max. It's clamp 0 to 1 value minus range min by max minus min. Clamped and then lerping. Everything's good. I don't know. Oh, Jack F. Hardy joined. Hello. So, tell me, chat, what the hell did I do wrong that it's so kicked to the side? Or maybe it's just this. No, it's okay. It doesn't change a thing. Huh. Or maybe this polar is wrong. This polar thing. That shouldn't be, no. Angle is arctangent fast. Let's try arctangent. Without fast. Nope. What the hell? Minus pi to pi 0, 1 angle. Okay, I think I know. Comp mask. I think I know. G and then append in the reverse order. Nope. No, it was okay. I don't know. To be honest, what's wrong? Where is the vector to? Why is it not symmetrical? Like, this is the crazy part. Where does it break to stop to be symmetrical? There is distance. Oh, wait a second. Distance to 0, 0. Or maybe to half and half? No. I don't know. Apple space, yes. Scale over V1. Multiply. Yeah. Shape is float. Is it? Where's the shape? Ah, shape is this polar cosine thing. Cosine of angle times pi added pi. Polar angle of UVs. No idea. Completely. And then it's multiplied by this final shape. Wait, are all of these scalars? Yeah, they are. I don't know, something's wrong. Let's try it like that maybe, but I'm really perplexed by this. This is weird. This is weird. Okay, and just output the space. Debug review. Great. Now where is it used? Apple space. It's in calc fruit UV. Okay, so we just output this Apple space. So calc fruit UV. You know, I want to cut on time because we already are doing it long. There's the background, cool. There will be this Apple space thing. Just the UV. Main UV and fruit type, yeah. Main UV. Ah, just flipped Y. Okay. And added something. Whoa. Ah, because it's to have many fruit. Let's try one for now. Okay, we take a distance out of this. Distance. So this space, this Apple space, is the same thing as I shown in the signed distance field video. Signed distance field. Piatnashkin says it's a feature, not a bug. The Apple kicked to the side. So here I explain signed distance fields, and this is what exactly this Apple is returning. That's why I added a test and if it's bigger than 0, because signed distance fields here are 0 at the edge. Not exactly here, but in general. This one is a little skewed. So what I need to do is to calculate the distance from this apple UV, this banded UV banded in the shape of an apple. I need to take a distance to 0. Distance to 0. Dist, and then out of this distance I can derive multiple things. So peel will be the step between fruit distance threshold. What is fruit distance threshold? Ah, it's a collection parameter. Fruit distance threshold, yes. Plus edge softness, it's also a parameter. Yes. And plus, and there's also this, but minus. Oops, subtract. It's also shown in this signed distance field video. It's basically the softness of the edge. Okay. Move step from this to that. Using distance. Let's see what we got. This is the space. And this. Ah, but we also need to shift the UVs. So add 2 minus half Yeah, here it is, the shifted apple. And as you can see, it has a little smooth edge. It's not an if node, it's smooth. So much better than an if, just to use smooth step like this. Tiny threshold positive, tiny threshold negative, and just create a mask out of that. So this is our apple shape, the peel mask. Okay. Named weird node peel mask. Then there's pop. So the same, but slightly different. So the same, but adding 0.05. No, subtracting. Subtract 0.05. Yeah. And the smooth step again. Again from the distance. And this will be neighboring root. Pop mask. So this will be slightly smaller. This is that. And this is a little smaller. So if I append this tool, you will see the apple peel and the pop, right? So just subtracted this small number. Like this. Okay. And there's output color, which is a mix. Okay, so now from this point it's just a bunch of lerps. So lerp mix free color peel and fruit type. Because it originally blends between banana color, apple, and so on. So yeah, seed mask, sure. Seeds mask. What's the original color? Seeds are one thing, but color seeds. Where's the background? BG. It mixes BG and the peel first. So first it mixes BG and the peel using peel mask. So peel color 0. Then it mixes the result, with pop, color pop 0. And 2 outputs. Arithmetic incorrect. What the hell? Sorry. Comp mask RGB. Yay, we have that. We have the thing. So 2 shaders partially ported from ShaderToy. One is that one, right? And another is the normal map. Okay, so this is it for today. Already quite long, quite exhausting to be honest. Especially this, how much time it took to copy the parameters, the text, the colors. But hey, we did it. It works. So thanks a lot, and see you soon. And see you on Discord too. Cheers.